All right, we're going to start this out with finding the slope of a tangent line to a polar graph. And we can use these two facts that we talked about the other day, where x is equal to r cosine theta and y is equal to r sine theta. So the slope of your tangent line is going to be dy dx. And similar to the parametric equations, we can get the slope by finding dy d theta divided by dx d theta, because if we divide these two things, the d thetas will cancel out, giving us dy dx. And so if we take a look at the information that we start with right here, dy d theta would equal first times derivative of the second, so that would be r times cosine of theta. So that's the first term times derivative of the second, because we've got a product rule going here. And then we have plus the second, which is sine theta, times derivative of the first, which would be r prime. And then we are dividing that by dx d theta, where this is x, so that again is going to be product rule. So we have first times derivative of the second, so that's going to give us r times negative sine theta, plus second times derivative of the first, so that's cosine theta times r prime. All right, so remember that r is going to be a function in terms of theta, and so what this simplifies down to, or converts to then, is going to be f of theta times cosine of theta plus f prime of theta sine of theta over, and then negative f of theta sine of theta plus f prime theta cosine of theta. All right, so that's kind of our formula that we can use for this stuff. Most of the time you probably are not going to try to memorize this formula, but just simply to use these derivatives, and knowing that you may be using a product rule with these. All right, so let's go ahead and see what I'm talking about here on this first problem. So it says to find dy dx and the slope of the graph of the polar curve at the given value of theta. All right, so we need to find dy dx. So that means we're going to need to find dy d theta and dx d theta. All right, so let's start out with a rule that we know, and that is that y is equal to r sine theta, which means r is equal to y divided by sine theta. Now we can use this in this way. We know that r is this right here. And so we can replace r with 2 plus 2 sine theta. All right, so what that's going to do is it's going to give us an equation in terms of y and theta, and then we can solve for y and then take the derivative, which will give us dy d theta. All right, so we will then solve for y, So that means y is going to equal 2 sine theta plus 2 sine squared theta. And now taking the derivative will be with respect to theta, and that means dy d theta will equal 2 cosine theta plus 4 sine theta, and then chain rule, cosine theta. All right, so that gives us our dy d theta. Now we need to find dx d theta, and we're going to use a similar process here. Knowing that x is equal to r cosine theta, that means r is equal to x divided by cosine theta. And we can use this then to find x over cosine theta is equal to the r, which we already know. We use the same value, 2 plus 2 sine theta. Multiplying cosine over to the other side gives us 2 cosine theta plus 2 sine theta cosine theta. And now we take the derivative, which will be with respect to theta. And so we end up with the first one, derivative of 2 cosine theta will be negative 2 sine theta. And then we're going to have a product rule here. So this is going to be first times derivative of the second plus second times derivative of the first let me go ahead and put this in terms of dy dx. So dy dx would equal dy d theta, which is this right here. So it's going to be this value over dx d theta, and I'm going to simplify that a little bit. So that's going to be negative 2 sine theta and then you're going to have, let's see, minus 2 sine squared theta plus 2 cosine squared theta. Now, every term has a 2 in it, which means we can actually factor that out and get our simplified answer here, which will be dy dx is equal to cosine theta plus 2 sine theta cosine theta over negative sine theta minus sine squared theta plus cosine squared theta. All right, so that is what your slope is, and again, that is in terms of theta. All right, so it's depending upon the angle that you are rotating at. Now, this does say that we are finding this at theta equals pi over 2. All right, so now we need to evaluate this at pi over 2. Well, cosine of pi over 2, that's 0. actually do this in black. So it's going to be 0. Sine of pi over 2 is 1 times cosine of pi over 2 is 0, so that means this term is actually going to end up being 0. That's going to give us 0 in the numerator, and it doesn't matter what the denominator is, because 0 divided by anything is going to give us 0. All right, so the slope of the tangent line at pi over 2 is going to be 0. It's going to be a horizontal line. Okay. All right, let's look at the next part here. It says to find the points of horizontal and vertical tangency to the graph of r equals 2 minus 2 cosine theta. All right. So let's think about the direction that we need to go with this. A horizontal tangent means that your slope is going to be 0, and if we think about dy dx is equal to dy d theta over dx d theta, so if we think about this right here, dy d theta over dx d theta. For a horizontal tangent, that means that dy dx equals 0, which means dy d theta would have to be 0. And then for vertical tangent, a vertical tangent has a slope that is undefined, and dy dx is undefined when your denominator is 0, which means dx d theta would equal 0. So what we'll need to do is for the horizontal tangents, we'll find when dy d theta equals 0, and then for the vertical tangents, find when dx d theta is equal to 0. All right, so that's kind of the direction that we're going with this. So the first thing, let's go ahead and find the vertical tangents. All right, so for the vertical tangents, we're going to need to work with x. All right, so remember that x is equal to r cosine theta, which means x is equal to, since r is 2 minus 2 cosine theta, that gives us this. We can distribute, which will give us 2 cosine theta minus 2 cosine squared theta. Now we need to find the derivative. So dx d theta will equal, the derivative of 2 cosine theta will be negative 2 sine theta. And then we have the derivative of 2 cosine squared. Well, that's going to be plus 4 cosine theta sine theta. That's because of the chain rule. And we're trying to find out where this is equal to 0. All right, so with this equation, we can factor out a sine theta. That leaves us, let's actually factor out a negative 2 sine theta. That's going to leave us with 1 minus 2 cosine theta equals 0, which means negative 2 sine theta can equal 0, or 1 minus 2 cosine theta can equal 0. All right, so in order for this to equal 0, theta has to equal 0. And x could equal pi. That would also give us 0 right here. All right, so the next one we're going to do is solve for theta over here. And so that means you're going to subtract 1 and divide by -2. So cosine theta is equal to 1/2. And that occurs at the angles pi over 3 and 5 pi over 3. All right, so now let's work on dy d theta using the same process over here. So I'm going to start out with y is equal to r sine theta, which means y is equal to 2 minus 2 cosine theta times sine theta. Distributing is 2 sine theta minus 2 cosine theta sine theta. Now we find the derivative with respect to theta, which is going to give us 2 cosine theta minus 2, and then we've got product rule here, so that's going to be sine theta times negative sine theta plus cosine theta times cosine theta. So simplifying this down a little bit is going to give us dy d theta is equal to 2 cosine theta plus 2 sine squared theta minus 2 cosine squared theta. And we can actually simplify this down a little bit here using property from trigonometry, where sine squared is equal to 1 minus cosine squared. And so this is going to become this. Then we have minus 2 cosine squared. Alright, so we end up with 2 cosine theta. Distribute the 2, it's going to give us plus 2. Then we're going to have minus 2 cosine squared theta, and we have a minus 2 cosine squared theta here, so those will combine together for a minus 4 cosine squared theta. We're trying to find out where this is equal to 0, and so we can divide this whole thing by 2, so 2 in common, and that's going to give us, actually we're going to divide everything by -2, and dividing by -2 is going to give us 2 cosine squared minus cosine theta minus 1 is equal to 0. We can factor this down to 2 cosine theta plus 1 times cosine theta minus 1 equal to 0, giving us, setting each of these equal to 0, cosine theta would equal -1/2, and this one would be cosine theta is equal to 1. Over here, theta would equal 2 pi over 3 and 4 pi over 3. Over here, theta would equal 0. Now, remember that your slope is dy d theta over dx d theta. Well, we cannot have 0 here and 0 here, because what that would do is it would end up giving us 0 over 0, which is an indeterminate form, and so those two values are not going to be valid. So that's going to give us, our solution is going to be at pi over 3, pi, and 5 pi over 3. And those will be your vertical tangents. And then your horizontal tangents will be at these values over here, which is 2 pi over 3 and 4 pi over 3.